All right, here we are in Excel, and we already have our workbook set up a little bit. With the data over here, we have some space for each of the things we're going to calculate, and we have our mean, standard deviation, and our number of samples already calculated. If you want, you can go ahead and make this yourself. Otherwise, there is a link in the description with the workbook pre-made with all of the math in it, but you can just go ahead and delete that if you want to follow along, or it's already there for you, so you can just use that. Awesome. So to start, we're going to start filling in our indices. And something to note about the Ryan-Joyner test is that it uses a zero-based index system. So we're going to want to start with 0. So we 0, 1, and then drag all the way down, make sure we get all of them. And then yi is the next thing, and yi is just a sorted array of your data points. So we sort them. There we go, an ascending order. Now, TI, if you remember from the math section earlier, is a transformed index. And the formula for this is going to be I plus 1 minus 0.375. Then we divide that by n, and we're going to make sure that we absolute reference that with F4, and then plus 0.25. Awesome. So now we can go ahead and double click that all the way down. Looking great. We should see that this looks almost 0 and that's almost 1. Perfect. And now we're going to take the normal score of that. So norm.s.inverse. And then we put in our TI. And double click to fill down. Now yi times bi, that's going to be used in the numerator. And so we just multiply yi and bi of each row. Let that go down. Now, yi minus y bar squared, yi again will be the same yi, so we'll use the power function here. I like to use power function. I think it's a little bit cleaner. We take yi minus, y bar is our mean, so again, absolute reference, and then we square that. Enter. Perfect. Double click to drop it all the way down. bi squared, again, use the power function, and then we can just square it like that. Perfect. Double click to drop all the way down. Now we're ready to start collecting our correlation coefficient. So the numerator is just the sum of that yi times bi column. Perfect. Our denominator gets a little more complicated, so it's going to be square root, open your parentheses, then it's going to be sum. And the first sum we're going to do is the yi minus y bar squared. Then we multiply that by another sum, and that's our bi squared column. Close parentheses and close one more time, and enter. Perfect. So now we have our numerator and denominator. We can come down to here where we have rj. That's the same as rp. And we will do equals numerator divided by denominator. Wonderful. All right. So now we have our Ryan-Joyner test statistic. What we need to now find is our critical value to know whether or not the non-normality hurts. So we're going to make it so that it uses this table, and we can plug in whatever alpha value we want. So the first thing that we're going to do is let's just put in an alpha value. To start, we'll do 0.05. Okay. The reason we did that is because we're going to be doing some math. We're going to be doing some if statements, and it's always easier to check your if statements if you already have a value passing in. So we're going to say if alpha equals 0.1, then our value if true for B0 is 1.0071. Else, we're going to do another if statement. We're going to say equals 0.05. Then our B0 value is going to be 1.0063. Else, we're going to do 0.9963. Okay, so there's no error checking in here. So if any value other than 0.1 or 0.05 is there, it's going to use a significance of 0.01. So just make sure that you're only giving one of those three values. Those are the only values that we have for the Ryan-Joyner critical values. So then we close our two parentheses, enter. We get 1.0063, perfect. All right, so now we're going to do the same thing. If that equals 0.1, now for B1, it's minus 0.1271, else if that equals 0.05, now it's minus 0.1288, else then we do our final one, 0.0211. Close up our parentheses, enter. Minus 0.1288, perfect. Same thing again, equals 0.1. Then our value is going to be minus 0.3682, else rock another if statement here, equals 0.05. Then we are going to have minus 0.6118. Final value minus B2 1.4106. Close up our parentheses. Last one here. And another if statement equals 0.1. Then 0.778. If L7 equals 0.05, then 1.3505, else 3.1791. Close them up. Let's double check. B naught is 1.0063. B1 is minus 0.1288. B2 is minus 0.6118. And B3 is 1.3505. Perfect. So now our critical equals B naught plus, and I'm going to put this in parentheses, we have B1 divided by the square root of n plus, put it in parentheses again, B2 over n plus B3 over power n squared. Close that, and enter. And there's our critical value. Awesome. Let's double check against the QE sweep function just to make sure we got it right. Select our data. And there we go, 0.98094, 96389. Perfect, we have the correct values. So in this case, our Ryan-Joyner test statistic is greater than our critical value. Therefore, we can assume normality. Excellent. So that's the math behind the Ryan-Joyner test statistic. Thank you so much for watching. Have a great day, and please do something awesome.